So we have number 22 from 2024 to 12B. So we have a triangle ABC with the integer side lengths, and we are given that one angle is twice of the other one. So the sides are integers, and angle B is twice of the angle A. And we want to find the smallest possible perimeter of the triangle. Okay, so the question doesn't really have much information other than like being integer size and one angle is twice of the other. So which is why I just wanna at least start with draw a triangle. So let's say this is A, B, and C. And as soon as we have that, so let's use the angle A. Let's say this measure is alpha. And then if you double that, you will get angle beta. So that is the twice as much. Okay, but now like we don't have anything like really that we can start with, right? So what we can kind of see, like this angle is twice of the other. It's gonna work out if 30, 60, 90 triangle, but if that's the case, one of the sides should be something times root 3, which is not integer. So it shouldn't be 30, 60, 90 at all. But other than that, we don't really have much tool, but we can use like, since we are gonna relate the sides with the angle, so which is a good job for the law of sines. So maybe you should do that. So I'm gonna say this is side A and B and C. So if I remember the law of sines, so just the side length, which is A, divided by the sine value of the opposite angle, so the sine alpha, and this is equal to, so side B divided by sine value of 2 alpha. Okay, so we can write the C, but we don't know the angle, so maybe we shouldn't try that at all. So this is something we have. But when we have this sine like 2 alpha, which is double angle, so if you remember sine 2 alpha, so that is equal to 2 times sine alpha times actual data, sine data times cosine data. This is double angle for sine, which is really common. So we can just expand this, like if I want to cross multiply first, so that should be B times sine like alpha equals A times sine 2 data, which is equal to this quantity. So that should be 2 times sine alpha times cosine alpha. So we can easily cancel these. And then we got B equals 2 times A times something. So that is something, right? So we have at least B equals 2A cosine alpha. But with this only, it's not really kind of helpful because we have no idea about the angle alpha, so we cannot really use that. And maybe we should try find another thing so we can kind of relate that. But only way that we can kind of relate this cosine alpha, maybe we can use cosine, law of cosine as well. So if I use law of cosine, but I like to use in a way that I can actually use the cosine alpha, which is why I'm going to use this angle, which starting with this side. So if you kind of don't remember the law of sine, law of cosine, or double angle, so I'll attach some additional like videos. You can review those backgrounds, but I assume that you already know. So the square of the opposite side, so just a square, equals the sum of the squares of the other two sides, b squared and c squared, minus 2 times b times c times cosine alpha. Okay, so we have this, but we need to relate this with this one. Maybe we should get this cosine alpha alone and plug into the second equation. So if I divide by 2a, so b over 2a will be cosine alpha. So now we are going to plug right here. So that will give us a square is b squared plus c squared minus 2 times b times c. And that will be replaced with b over 2a. So we can cancel this. Let's multiply by a. So that should be a cube. Okay, so when you multiply both sides by a, so you got a cubes, and then that will be a b squared plus ac squared minus b, actually b is gone, So we got b squared times c. Okay, so now we are done with the angles, but now we have sides in a way that they are kind of complicated in the equation. So there's no easy way to kind of find those like integers. So we just need to try to eliminate somehow the equation in a basic form, if possible. The factor is usually the best thing we can try on those cases, so we can kind of see some cancellation. I have b squared and I have b squared as well. Maybe I can pull those together. So let's try that first. B squared. If I take b squared, so you got a out of, and then minus c. And then maybe I can move this on the other side because I can like pull the a's one side. I mean, I can pull the a as a common factor. So that should be a cubed minus ac squared. Since I have a in common, so I'm going to pull that a as well. So that should be a squared minus c squared. Okay, this is promising. So since the right side has a minus c, this is different side squared, we can take this guy as a minus c and a plus c. So a minus c and a minus c will cancel. So you got a times a minus c is equal to b squared. Okay, so let me double check. So that's b squared and c. So we have this equation. Okay, so far, this is somehow like useful because I can kind of write the a times a minus c equals b squared, but let's double check. So a squared, b squared, c squared, so minus 2bc, and then multiply by a, so ab squared, ac squared, and minus b squared c. So we pull the b squared, so that will be a minus c. And then when you subtract this from both sides, you got a cubed minus c ac squared. So, okay, so we cancel these. Oh, we cancel a minus c, so this has to be a plus c. Okay, so now we have this. This is slightly better because we have a less complicated version of the equation. But the problem is, how can we deal with this now, right? So we can just kind of try guessing those values until we hit one of those smallest number, which is possible. But instead of doing that, let's try to write a, b, and c in terms of like one variable if possible, so we can kind of start with that and then try to get a, b, c as small as possible. But to do so, we just need to recognize, since we are trying to find the smallest value of the perimeter, so a, b, and c should be relatively prime. Because let's say if they are not, let's say a is like 6, b is 4, you can always take the half. I mean, if you can take the y by 2, then you just make those numbers smaller. So if they are not relatively prime, but if they are relatively prime, then there is no way to get smaller than that. So since like a and c is relatively prime, and if you add a and c, a plus c and a should be relatively prime as well. Because if they are not, so if a and a plus c has a common divisor, so you can still simplify those, so which is why we don't want to have that situation. So, but the problem is, we multiply two numbers that's relative prime to get a perfect square. So that means a and a plus c should be like perfect square separately as well. So, which is why I'll say, let's say a equals like m squared and a plus c is equal to n squared, but since a plus c is larger than a, so based on that, we should say m is lesser than n. So let's remember this relation. And since we said this is m squared, this is n squared, when you multiply, you got mn squared, so which means b has to be m times n. Okay, so like somehow we relate a, b, and c in terms of m and n, so at least like 2 variable better than 3. So I'm gonna try using that. So if I try kind of make table, so I can kind of organize my result. So let's say this is a, this is b, and this is c. A is m squared, and then b is mn. Okay, and then c, if I take this equation, c is n squared minus a, because if I know the a, so I can kind of write c in terms of that, which is probably helpful. So n squared minus a. So now we have like two variable like m and n, even though a is right there, because as soon as you determine m, you actually know this one anyway. So which is why you have only two variables, it's better than three. So now we are going to start with the smallest one. If I choose m equals 1, so that will be m squared is 1, and then that will be just 1 times n, which is n. And then the n, we don't know yet, so that should be n squared minus a. A is 1. So the question is, do we have such a thing? And remember, m is lesser than n. So, but in this case, if I choose m is 1, then n could be like, let's say, if m is 1, then n could be 2 at least. If this is 2, then this is going to be 3, so that should be like 2, right? This 2, and then this is going to be 3. But in that case, 1 is A, B is 2, C is 3. That is not correct because triangle inequality doesn't satisfy with this 1, 2, and 3. So which is why it doesn't work. If I choose this is 3, right, for like n, that will be 8. It doesn't work either because 3 plus 1 is smaller than that. So it doesn't work because we are going to square that. Whatever you choose for n, so it doesn't really work well. So which is why for the case m is 1 doesn't work. So if I choose m equals 2, so that means this is 4. So I mean that b will be 2 times, this is m times n. M is 2, which is 2n. And then this is going to be c, which is n squared, which we do not know yet. So, but a is like now 4. And the goal is to see if there's a like value of n to satisfy this condition. N is larger than m, so if that's the case, so we can try, let me see, m is 2. If m is 2, right, that means n could be 3. So if I choose m is 3, so that will be 6 for n is 3. So that will be 9 minus 4, which is going to be 5, which actually works. So 4 for A, 6 for B, 5 for C, which add up to 15. So since we couldn't get anything with when m is 1, because we need to get ABC's integer, and then we need to try m is 2, and then when we did that, so we actually got that integer values for each. So that is the smallest one. If you try more, you will get some other integer, but that will be bigger than what we have. So that's why smallest we can get is 15. So again, it wasn't really clear at the beginning how to start, but using some of the like background, like law, sine, law, like cosine, because we are relating the sides and the angles. So that was like helpful. As soon as you end up getting some equation, so the rest is just using our algebraic manipulation to get what we want. Okay, so anyways, I hope that was clear. I'll see you in the next video.